All right, so I'm Dr. T. Let's go through all the information you already know, but I'm Dr. Trenery, and I prefer Dr. T or Professor T or whatever, and I should have what you would like to be called somewhere. Where'd that go? Asha, thank you. Appreciate it. And I'll have all that down. We're doing Calc 1 in here. So we will start off with the basics. We will end up right, if you have had Calc, we'll end up right at the beginning of integration. So if that's something that makes sense to you, if that phrase makes sense to you, that's where we're going to end up. If it doesn't, cool. We'll talk about it. I don't assume you know any of this. My office is in Carroll Hall, and it's 108F. So if you go into the astronomy, math, physics suite in Carroll Hall, walk all the way to the back of the hall. My office is the last one on the left. And I will be in there right before this class, Monday, Wednesday, and Friday. So for about an hour and a half right before this class. Tuesday, Thursdays, I've got some weird stuff going on. I'm teaching also in the Inside Out program. So that means I'm working with a bunch of incarcerated folks this year at Lyman. And so I do an online stuff with them, and I travel out there pretty regularly. So first half of the semester, Tuesday, Thursdays are like, but I'll meet with you by Zoom if you need it. So if you can't see me these times, you know, the times right before class, I think it's 11 to 12:20. Monday, Wednesday, Friday. If that doesn't work for you, you already know that, and just reach out and we'll set up something. We will always work together. Don't be afraid to ask for help. Super important. So, what is this class based upon? What's your grade based upon? So we're going to have we're going to have 4 exams. And 3 of these are like classic exams. They're going to be in class. You can have a sheet of notes. Probably not a calculator. I'm trying to help you get strong. I know, don't. It's okay. I thought that was like, I've had people run screaming into the night when I tell them they can't use a calculator. Not even a graphing calc? We will see. In general, they won't need it. I'll make sure that it's not. You don't have to know what's pi times e. Oh shit, I don't know. Okay. Don't worry, I wouldn't do that to you. But if you do know 2 times 3, and you're good. I just need to know if I can get one. Oh, don't worry about it. Okay. Yeah, I wouldn't get one. Because honestly, a lot of your work is probably going to be, if you need a graphing calculator doing work in this class, I would go to desmos.com. The greatest graphing calculator in the world. Just absolutely free, absolutely astounding. Love Desmos. We'll be popping it up a lot. So we'll have 3 classic exams, review, come in, tell me what you got. And then one of them is like a take home, and that's the 3rd exam. It's stuff that would be not fair to ask you to do under duress in a short period of time. They'll be like word problems. So I give you time. My goal is for you to get an A. I want you to get an A. And I'll do everything in my power to help you get an A. And hopefully no one in here will do everything in their power to fight me on that. But some folks just gotta fight me on that A. They got to. They'll just do everything in their power to not get an A. I hope we're not rolling like that this semester. We will also have, so these are going to be, this is like 60% of your grade right here. These are like 15% each of these 4 exams. The rest of your grade is going to be homework. So the remainder of your grade is going to be a system called web work. And we'll talk about that in just a minute. And then we'll have occasional quizzes and then written homework. So this is great. What's cool about this is the quizzes are going to be like super basic stuff. Definitions. Do you know what this word means? Not like hard stuff. Just so that you have the definitions down. And we're going to have a quiz actually next Friday. Next Friday, not this coming Friday. September 8th, we're going to have a quiz. I'll tell you more about that in a little bit. It'll be very simple. It's stuff that I want you to know because you need to know it. You have a homework that opens. You have 2 homeworks already this semester. So if you go into World Class, log into our page, you'll see on the right-hand panel dates for things that are coming up. So there's 2 things. This is the first one you can do right as soon as you leave here. So homework primal or something. We'll call it primal. I didn't even give it a number. Homework primal is go to the content area of World Class. So go to our World Class page, go to the content area, go to the web work section, and log in. The easiest points you will have all freaking semester are this homework right here. Log in and try anything. Don't even get it right. In fact, I challenge you to not get it right. Go in and put a garbage answer in for something. Unless you're like, you can't do that because it hurts your soul to do that. That's cool too. But what I want you to do is log in and attempt 1 problem. Okay? The way you log in is described in this web work post. You're going to use your student ID as your password, and the prefix of your Regis ID is your login. So, in other words, if I was goatboy732 at Regis, here's my login name, and my password is my social security, not my social security number, my Regis ID number. So do that, try anything, and what I'd love is that you did this by Wednesday, so that we can if there's problems, we know. I don't want you having to wait till after that. So please do this. Do a start of class Wednesday. Now, if you're a person who thinks you will forget this, you probably know that already. Put a reminder on your phone. I hate being a cop. I'm just not a cop kind of person. It's cool. Cops are cool. We need cops. But I can't be a cop. I hate having to nag on you. Don't make me nag on you. Please, just do this. So do it start of class Wednesday. Do it tonight. Do it tomorrow. You'll be golden. And you'll get you'll get a relatively good amount of points. After you do that, there is a homework 0 in web work. Start it. This is due next Thursday. So you'll need to have it completed by Thursday. Now, what's cool about this, friends, do not miss out on this opportunity to get a perfect score. You have complete control over this. You can work each problem as many times as you need. And what I'm going to beg you is don't let ChatGPT work them. The high temptation, especially if you've worked it a few times, you're like, I'm so fucking sick of this. Okay, take a screenshot, give it to chat. How do I do this? The reason I say don't do that is because the quiz is going to be based on these problems. So if you can do these, the quiz, I'll just grab 1 or 2 of those and we'll call it a day. But please, for your own sake, build your own muscles. Anybody here a bodybuilder? That's kind of, you're doing lifts, you do lifting and stuff. You don't have other people lift for you, right? Get you nothing. Now you can tell I do my own lifting. I kind of do, but I kind of try. But just please build your strength this semester. Let me know if you have any troubles. If you're like, help, I don't even understand this question. Wouldn't it be cool if I knew that on Wednesday and we could talk about it? I will every day at the start of class say, anybody want to talk about anything? And we'll talk until you are good. And then I'll start my show, whatever. But it's about you. I'm here for you, and you have to kind of take it by the reins, right? It's your education. I can't make you do everything. So do that, please. And then there's that quiz next Friday. based upon these homework problems. And so that's it. That's how things are going to roll. Is any questions on this? Okay, cool. All right, thank God. We can start doing fun things now. Yes, question.
So there'll be quizzes like every other week?
Probably something like that. Yeah. So like this quiz, and actually let me add something to that's a great question. On the quiz next week, so we'll call it like quiz 1, there's definitely one thing that I want you to know on that, because I think this is a super important thing for a technical person, a scientific person, business person to know. If you're in Calc, you should know this. I want graphs. I want you to be able to reproduce graphs of sine of x and cosine of x. And I'll show you what I mean by this. We will do this, and I'll show you how to do it and help you. But I want to be able to see a graph of each of these labeled and just beautiful and all that stuff. And this will pay off in a way you can't even imagine. I promise. And then, and a few web work 0 problems. Probably 1 or something like that. And I'll literally make them. I'll take the problem, change the numbers. So if you do the web work, you're good. Does that help? Does that feel good? Okay, cool. And I'll never pop quiz you. I'll never give you less than a week's notice on things. Our exams, kind of the same. We'll work at the rate we need to work, and then we'll have the exams. If it turned out for some weird reason that we're really behind the ball and we can't have all those exams, we'll talk about it and figure it out. Everything will change to help you if it has. Nothing will ever change to be against you. Okay, we good? Questions? We're good? Woohoo! Let's go. Okay, so our book is free. I hope you didn't buy. Nobody bought a book, right? Good. No, there's nothing to buy. You never know. The bookstores are kind of like mobsters. They are. I don't like bookstores. I don't like campus bookstores anyway. They just screw you over. So that's why everything we do is free, if possible. So our textbook is Active Calculus, and I've got a link to that in the content area of our course page. Please check that out and read. Do as best you can. If you're not sure how to read a math book, let me know. We'll talk about it. I would just like you to read section 1.1 just to get warmed up. Just kind of skim through it, right? Look at the examples. The examples will let you know. If you can read the examples, you got it. Okay. But we will cover most of this today. So let me just make sure I haven't missed anything pertinent that I want to tell you. That's the next class. That's not this class. There they are. There's my notes. All right, cool. So let's talk about velocity. Let's start off with some applications. Do we have any physics majors? Physics. You like physics. You're into physics. Major? Fan of physics. So yes, lover of physics. Awesome. Cool. And it's okay if you're not. Don't worry. But it kind of helps talk about calc to talk about some simple things. So don't worry. Just chill problem. I've got this particle that's moving. And think of the particle as me. So I'm moving across the room. I'm the particle. Now I'm moving backwards. Now I'm moving forwards. Now I'm moving backwards. So let's say I'm the particle. And over here on the board, this is 0 right here. And it's 0 feet. So let's see. I don't know. How long? Anybody good at estimating how many feet you think this is? Shit, I don't know. 20, sure. Sounds good. Sure. Let's see. I like it. Sure. Who cares? Nobody's going to check on us anyway, right? We're not building anything, hopefully. I'm not building anything. So I want to think about describing my position on this line relative to time. So I'm going to make this axis time, and that's going to be in seconds. And I'm going to make this axis position. And position, so let's put t here as the variable name. Position has this very standard kind of function notation. S of t equals the position at time t. So let's think about this with me moving, and just so we can get a really good handle on this. Is this looking okay to everyone? Is the glare okay? Cool, Joshua, no glare or anything? Okay, awesome. And then let's get another color out. This lovely cyan, that's a good color. So let's just think about this trip that I'm about to take. So remember, position. Right now I'm at position 0 at time 0. So I'm going to put a little dot there. I'm starting at position 0 at time 0. And I'm going to walk across 1,000, 2,000, 3,000, 4,000, 5,000, 6,000, 7,000, 8,000. So it took me like 80 seconds, 8 seconds to get across there. You know, none of this is rocket science. But at 8 seconds, I was at the 20-foot mark. Let me know. Tell me if that's making sense. And if not, let's talk. Guarantee you, if you're like, what is he talking about? You're not the only one. Please, please get in the habit of raising questions when you're not sure. So for this one, I was kind of just like walking across at pretty steady rate, right? I didn't change how fast I was going. I didn't slow down. I didn't speed up. I didn't slow down. I didn't go backwards. So I just kind of walked at on a path that maybe looks something like that. And we're going to get into why. We'll talk about why that is. You might be like, why is it straight? We'll get to that. Let's talk about a different path I could have done. So maybe you can help me. You can help me figure out what the graph would look like. So take a minute. Come up with on your paper, what does the graph of this motion look like? Position, start out here. I'm going to end up here. So you're going to fill this in with a different graph. So see if you can just come up just intuitively. You do have a clock in here. We have a code. Oh boy, that's a good clock. Oh, out of paper. Sorry.
That's all right.
You know what? I got some. I'll give you some extra too. You can. Yes, absolutely. You bet. Let's see. I think I got more in here. But probably want to bring some paper. You seem like a light traveler. I like that. I think that's cool. But a little paper never hurt in school, you know. You're so welcome. Anybody care to put the graph up for us? That's a lot. That's a bold move to ask for the first day. Eventually, I'll call on you. But I won't do that today. I promise.
Do you get bonus credit for doing that?
No, well, you get in my heart. Little extra spot of love for you.
I'll take some.
Okay, oh, everybody needs love. And you can pick the color. Okay. Oh, I like it, Zeus. Could you just really quickly, while you're there, sorry, I know I suckered you in. Now I'm going to ask you a few words of why you decided on that.
The previous graph was linear, your movement was static, as in the same pace, and then the movement you did was exponentially increasing. So it's an exponential graph.
Absolutely. Love it. Let's talk about why. So I'm going to get in here and explain in a different language. Oh, thanks. Thank you. You get a pat on the back, Sue. Sorry. I hope that was okay. I apologize if that's okay. We got this problem. I'm trying to not pat people on the back, on the shoulder. It's like I'm a hugger. And try to keep out of prison or something. At least keep my job. That'd be good. So let's talk about what Zeus said. Did anybody else come up with this graph? Yeah? Anybody have something slightly different? Should we get something a little different? No? Okay, cool. All right, nice. Well, let's talk about a way to explain what Zeus said, which was beautifully said, that when I first started, my first trip was a linear change. It looked like a line because my rate of change, my velocity, never changed. But when I was doing this, the distance I cover over the same amount of time changes as I move toward this end. So how can we see that in this picture? Let's take a look. Let's do it in red. As a math, I got to tweak this guy just a little so it looks a little more function. It's a little too vertical for my math mind. Is that okay? Yeah. Just a little bit. It was almost not a function there. There we go. That's good. Same idea. So let's take a look at the time frames here. So this is 4, 6, 2. And let's get a few little key points here. And we're just going to make some things up. But let's say that this was 1 foot. That actually looks somewhat that looks potentially a 20th. Doesn't look crazy. Let's say that this one is 2. And this is in feet here. And then this one looks like, I'm going to say 8, even though it looks a little under 8. And then this last one was 20. We got that right there. So let's talk about average velocity, because that's really, that's what Zeus was noticing. That's what you noticed, my velocity. But you're in your brain, you are averaging it, whether you know it or not. So let's talk about, first off, some notation. If I say AV of sub T naught to T1, so this is a little interval of time. And I said T naught, but I just mean T sub 0, if you've never heard that language. And sorry, Zeus, you can see, okay, cool. Interval of time from T naught, T runs all the way up to T1. So this is just some different notation for this interval notation. And this stands for average velocity. So the average velocity is just a simple ratio. It is the position at the end of the time minus the position at the start of the time over the change in time. And I'm going to write that this way, give you a second to write it, and then I want to write it a couple other ways so that we really understand. What time is it actually? Because it's not 3:15 or 3:10. 1:07, thank you. Let's do what should have been done a long time ago. Or Or you don't. Okay, no wonder it's wrong. No one knows how to change it. Okay, so this is just 2 hours ahead, actually, right? Okay, cool. We got that. We'll work on that. Wow. The inner workings of Regis. Scary. Okay. So, change in position. Here's what I'm going to write it again. This is the change in position. Notice I'm not saying distance. I'm saying position, because that's different than distance. And this is the change in time. And I'm going to do it one more way because we're going to get a little more calculus-y and introduce some notation that I'll use often. I'm going to put a big capital letter delta. So that's the Greek letter capital delta. And I'm going to put S. This stands for change in S, the position. So this is change in S of t divided by the change in time. And this right here is the heart of this entire semester. What is Calc 1? Let's talk about what Calc 1 is. Calc 1 is about subtraction and division. You might not have ever heard that before. Calc 2 is about addition and multiplication. Just very fancy versions of these things. Calc 1, we take differences and we divide them. This is the heart of everything we will do this semester. And if you had Calc already, you know the word derivative, maybe. And that's what this is getting towards. But we're not going to say that yet. We got to work. We're going to build up. And if that word is scary, don't worry. It won't be. It'll become the love of your life by the end of the semester. You're going to be so stoked about calculus and taking derivatives. You will. You will. I'm telling you. Oh, God, no. This is going to be better than high school. Okay, so yeah. I mean, I don't know. Sure. I'll just say that. But yeah. Oh, I know. It was rough.
It was fun, but it was definitely an adventure.
It was what?
It was definitely an adventure.
Okay, cool. I like that. I mean, this is going to be an adventure, but you've kind of already taken the adventure before, so you're kind of a pro. So it's going to be, yeah.
I'm not a pro, but it has been 4 years now.
Oh, a lot of things will wake up as we go through this. Yeah. Is there any questions on anything that's just happened at all? Anything I can clarify? We're good? Okay, cool. So let's actually do a few over here. I will get some light on so that we can... Sorry, I want the front lights. Do you all like that kind of the light the way it was before? Yeah, me too. I'm a low light. We'll get some candles and stuff in here. Let's see if I can get me just a little... That's a weird sound. It doesn't sound good. Sorry, Zeus. I just need a little up here. Okay, so let's find some things. Using that graph, what is each of these things? See how chill this is so far? No, sorry. What I meant was 0, 2, 2, 4, 4, 6, and then last one. Let's just find these quantities. Using that graph. So we're slowly waking up those brain cells, remembering how to use graphs. And we're getting to do probably one of the most blessed things a person can find themselves doing on this planet. Learning in a nice cool room. learning calculus, which is one of the greatest accomplishments of the human race. That's all. And you think, you hear Newton. Isaac Newton discovered calculus, and is like, oh, it's some white dude in a powdered wig, of course, some rich white dude, of course. But the calculus was happening long, long ago back in ancient Sumeria. So like the real people who came up with calculus were the Sumerians and the Babylonians. They were doing this stuff before thousands of years before Newton. And they were using this to compute things that they needed to compute. They used calculus to predict the position of Jupiter in the sky precisely. So like, what if that was this class? What if I just said today, okay, you got one project, give me a formula to predict where Jupiter will be next month. I fail the class instantly. No, I don't even know where to begin. So that just tells you, we think back to Babylon, the start of society, start of civilization. You think, oh, those guys, they were primitive. No, my God. They were so advanced. So advanced. And then old Newton comes along, kind of like scoops up some things. I mean, Newton was a smart guy, but he really was a rich-ass white guy who didn't have to work. Just sat in his tower and figured things out. Now I just made another list. I'm taking an extra step you may or may not have. I just like to write. I like to write math. And it helps me remember what I've done. And I hope you're not feeling stress from this. I hope not at all. And that maybe it's just nice to sit and work out some simple quantities together. S2 is 1. What are the units? Feet per second, right? Because on top, we've got feet. When you subtract feet, you still have feet over seconds. So this is a velocity, feet per second. And you want to maybe get used to thinking about keeping those units around. They help your brain. And if there's applications, you need that. Like this is how I did physics. I knew what the units were, and then you just work them around to cancel to get what you want. So then this is 2 minus 1 over 2. Huh. Wow, that's cool. I didn't expect that. That's neat. Am I right so far? Okay, good. Getting a little scared. Like I don't want to screw up subtraction and division in front of you the first day. That's like for next week when I screw up this stuff. Everybody cool on those first two, getting a half for each of those, half a foot per second on average. S of 6 is 8. S of 4 is 2 over 2. And so then that's 6 over 2, that's 3 feet per second. And then in that last little window, what do we got? We've got 20 minus 8 over 2. That's 6 feet per second. Good, cool. Yay, you're doing calculus, right? Not bad for a first day. Chill. Is there anyone who's uncertain about a computation that I've made and would like me to talk about any of these? But see, now we're seeing some mathematical evidence for the argument Zeus gave us. That as we moved through time, we sped up. for those first couple intervals, I mean, this thing here, this is, not much happens here. It's almost flat. And that's why you see the same rates of change over those two intervals. But then things start picking up. And here's what we just computed. These average velocities are simply the slopes of these lines that connect the 2 points together. So the slope of this, I'm going to use slope as m. The slope of that line segment, and it's actually called a secant line because it connects 2 points on a curve. The slope of that secant line is the average velocity on, for here, 6 to 8. The average velocity on 4 to 6 is the slope of that line. M equals AV, 4, 6. And similarly for these two. And you can see that the slopes of those two lines are very, like almost identical. It's really hard for me to even make them look different because they aren't different. So we good on this? Yay! All right, now let's have some more fun. Excellent. What kind of fun did I have in store? What is next? How can I be hungry already? That seems wrong. Okay, so you won't always get a picture. You will sometimes. We thought we'd start with a picture. Let's flip this around a little bit. Is it okay if I erase? Anyone still need to? No, okay. So let's kind of take the flip side of this. What if I gave you a position function? So given the position function, S of t is t squared. Let's get units here. So t is time in seconds. And this S of t equals position at time t, but I need a unit, let's say meters. So meters like 3 feet, it's like a yard if you're not thinking about meters a lot in your life. And we're in the US, so we use like cubits and weird nonsensical English units that are insane. So the metric system, we had a chance at the metric system when I was in grade school. There was a big push. Everybody was going to learn the metric system. But you know how America is. They just couldn't handle it. So that was, what a thing to protest. Okay, well, it was protested and it stopped. So what would this look like? Let me just take a second. Could you please make a graph quickly? What does this look like? Let's just see how much of that you might remember or how to approach that. You pronounced your name Kayla, right? Kyla. Okay, I knew it. I was like, it's not that. Okay, thanks. Thinking uncertain exactly how to proceed, or
I mean, I just don't have anything to put in t? I mean, are we just assuming t equals 1? Or
What a great question. I was just waiting for some questions. So what do you think t should be? Like, what should be the t range? This is great. Like, sometimes I'm going to do this. I'm just going to give you shit and like, well, I hope somebody asks where we're driving. Just get in the car. We're going. What do you think is a reasonable time here? What should t start at, maybe? 0? What were you going to say? 0. Okay, yeah, 0 sounds good. Okay, so we're going to say, so t is greater than or equal to 0. It's not a negative time. We could have negative time, but nah. We launched something at time 0, and it's easier to keep track of it. And I didn't really say when this could stop either, right? So this time could just keep going without bound. We don't really know. So I'm not going to put, I could put this if I wanted to answer the question if someone was like, what is the max time? I can say, well, no, there is none. You just can go to infinity. You can't reach infinity, so this isn't something you would ever want to do. We will talk about infinity later, but not yet. Or maybe that's Calc 2. I don't know where we get to that. So, Zeus, that's our time. Can someone help me? Let's see. Who's Kyla? Since I practiced your name. What did you think this looked like? Do you have an idea? Or how to approach it? What would you do to like just get a picture here? Start plugging in points, right? There we go. If it all fails, start plugging in numbers. See what happens. Connect the dots. So let's do that. Let's get some values. That's exactly the right approach. Unless you know what that shape is, and you might, and I'll ask in a minute. But let's say times 0. It's 0 squared, so 0, 0. Okay? 0, 0 is on there. Let's pick some other points. 1. 1 squared is 1. So now, as soon as I lay down this 1, I have set the scale for this axis. And as soon as I put this one, look, I'm going to make it a little lower. That's the scale for this axis. So now that's 1 unit on here. This is 1 unit on here. They don't have to be the same, but they have to be consistent. So 2 needs to be the same distance here and here. So notice how I'm using that to measure how far I've traveled there. I'm using this to measure here. So there's 2, there's 3, and let's go up to 4 because we're going to get pretty sick of